Big finish the ellipse. You guys finish that parabola homework? No. No finishing the parabola homework? All right. Passing math, you know what it's here. I feel a speech coming. I just last night was giving a small speech to my daughter. Who knows? It's true. She's anyway, so math, what it takes, to do well in math classes is every bit of the homework. So I encourage you to do that. Come get the help you need. All right, so what's the center of this thing? The center, yeah, because remember for center we always do opposite. And so that's the center, opposite. So what's the center of this thing? Positive 4, negative 4. That's the center. Remember how the center is always the opposite of the stuff that's in the equation. Is that good? That's going to be the case for all these sections in chapter 10. 10.2, 10.3, 10.4, hyperbola, ellipse, parabola. All of them. Center is opposite of the number in the parentheses next to x and y in the formulas. Okay, so that's the center. And what do we have? We have to do something to this equation. Let me rewrite it down here. We have to do something to this equation to make it in the right form. It's got to have the right look for us to graph it and find all the information about it. What is it? What do I mean the right look? What look does it need that it doesn't currently have? Equals 1, right? Remember, ellipse needs to be equal 1. So this, and that wasn't true for the last section, the parabola. The parabola was different. We had a 4, remember? We had a 4 and other stuff. We had x's and y's on other sides. But for ellipse, you've got to get it equal to 1. So that means divide through by 144. That good? So you got to get it equal to 1, so divide through by 144. Use your calculator. Over here, 4 goes into 144 36 times. So this will be y plus 4 squared over 36. This is x minus 4 squared over 144. Good, now it's got the right look, the look that'll be easier for us to graph. This is 12 squared, this is 6 squared. So now we can do the graph. Let's do that. So the graph, start with the center. Where's the center? Over 4, down 4. So there's the center of the ellipse. And now from that center, how do I find, how big the egg shape is? What do I do from that center? Where do I go to make the egg shape? Yeah, so right here, whatever's underneath x, that's how far right and left, right? Because x is always right, left. So whatever's underneath x, that's how far right and left. So I go right 12, left 12 from that center. I'm going to go right 12, left 12 from that center. How about I just put a dot somewhere over here and just go right 12, left 12. And then I go up, whatever's underneath y is up, down 6, down 6. So up 6, down 6. Put a dot. And then connect the dots. And there's our ellipse. And the center here is, again, 4 minus 4. Is that good? Does that make sense first off? So now they're going to ask me for a few different things. They're going to say, what is the what are the foci points and what are the vertices? Let's start with the vertices. Which ones are what does that mean, vertices? What do they mean by that? What do they want? All 4 edges? Do you remember what they want? They want the 2 longest. Yeah, so the vertices, here, I'll put it over here. The vertices are the 2 longest edges. Yeah, exactly. So when they say they want the vertices, they just want the 2 longest edges. And so the 2 longest edges would be right here and right here. They just want those two. If the ellipse was, if the egg shape was taller, than it is wide, then they would want the top and the bottom. But it's wider than it is tall, so they want the left and the right, don't they? So they want the left and the right. So how do I find that left point and that right point? That's sometimes can be a little tricky. Let me help with that. You basically, to find that, you just take the center, which is 4, -4, right? And then you just say, okay, I need to go right 12 and left 12. So that's going to be the x-coordinate, huh? I need to add 12 to the x-coordinate, so that would be 16 minus 4. And then I also need to subtract 12 from the center's x-coordinate. It would be -8 minus 4. Does that make sense? We don't change the y-coordinate, just the x-coordinate, huh? On that. Is that good? Just add 12, subtract 12 from the x-coordinate of the center. So we got the vertices. How about the foci, the 2 focus points? Where are those going to be? Are the focus points up, down, or right, left? Yeah, they're always on the longest direction, what we call the major axis. Did I talk about that? I can't remember what words I've said. I'm teaching that other pre-calc class. I forget what I've said where. Yeah, so this one is called the major axis, meaning it's the bigger, the longer. The up and down would be called the minor axis. So whichever direction is bigger, that's the important direction. So this ellipse is wider than it is tall. So that means the focus points will be somewhere on the major axis. They'll be, right and left somewhere on the major axis. The focus points are always on the biggest direction. So, okay, so that means I'm going to be adding and subtracting something again to the x-coordinate, right? But what? How do I find out exactly what I add and subtract to the x-coordinate? Do you remember? How do we find the focus? Remember, we have that focus equation, which is kind of like the Pythagorean theorem. So it's going to be the same thing. These two sections today are very, very similar, which is kind of nice. Same focus equation, basically. So the focus equation is a squared minus b squared is c squared. The focus will be the c. Remember that kind of thing? Okay, so the focus is the c. So a squared minus b squared is c squared. And remember, when two things are subtracted, you have to put the bigger one first. The order matters, doesn't it? And in a few minutes, when we get through 10.3 and we get on to 10.4, the hyperbola equation is going to be so similar. It's exactly the same as the ellipse, except instead of plus in the middle, it has minus right here. And then the focus equation for the hyperbola will have, instead of minus, plus. So it's exactly the same thing, just reversal of both signs. So the way to remember this, I mean, you can put on your 3x5 card, but the way to just know it immediately is the fact that whatever sign is in the main equation, for the ellipse it's plus, it's the opposite in the focus equation for that picture, for that shape. So for the hyperbola, they'll start with minus, what we do in section 10.4 in a few minutes. It'll start with minus, plus in the focus equation. For ellipse, it's plus in the main, minus in the focus equation. So it's reverse. Okay, so anyway, which one is bigger? Remember the A, when you look at this and this, or this and this, same thing. When you look at them, the bigger one's always A, huh? So the bigger one is this guy, and B is the smaller one. So 12 squared minus 6 squared is C squared, 144 minus 30. I probably should have just written 144 and 36 right away. Minus 36, I don't know what that is. 90 and 100, no. I don't know. 108. Thank you. 108. So 108, c squared is 108 when you subtract those, and then root it. So now what's this? You guys remember how to do the square root of 108? My other class had a lot of trouble with that, so that means I probably should review with you guys as well. Do you remember how to simplify square root of numbers from your algebra days? The other class was not so much. So let me go over that with you. Remember, you break it all down. Some of your calculators will do it automatically, and that's great if you got that. If not, let me show you. Just use your just divide by 2. I look at 108, and I don't know everything that goes into 108, but I know 2 goes in because it ends even, huh? So just start there. Just use your calculators. Go divide by 2. That would be 54, and then keep going. 54, I do recognize 6 times 9. So we just keep breaking everything down. So in fact, you know what? I need some more room probably. Let me go to a fresh thing over here. So 108, square root of 108. Again, 2 times 54. Break that down. 6 times 9. And 6 is 2 times 3, and 9 is 3 times 3. Bring this 2 down, and there's all the little pieces that make the 108. Do you remember how that works? So in other words, the square root of 108 is the square root of 2 times 2 times 3 times 3 times 3. That is the unique DNA, so to speak. That's the guts. That's the inner pieces of 108. No matter how you break down the 108, you'll always come to those pieces. There's actually something called the fundamental theorem of arithmetic, which says there's only one way to break down into primes. So anyway, so there it is. There's the guts of the 108. You'll always get to that no matter how you do it. There it is. Now, what does that mean about the square root and how we simplify the square root? Do you remember from algebra? 2-for-1 deal. That's what I tell my algebra students. Roots are a 2-for-1 deal. What do I mean? Well, think about, you guys know, what's the square root of 9? 3. You all know that, right? Mm-hmm. Do you see that 2-for-1 just happened there? What do I mean? What's 9? 2 3s in the root. What did that lead to? 1 3 out of the root. You see, that's what square roots always do. I don't know if you ever stayed up late at night and thought, hey, they're 2-for-1. Probably not. That's what weird math teachers do. But that's true, isn't it? That's what square roots really do. They're like shopping at Target this Christmas. My buddy was telling me that the stores already have Christmas stuff out. Is that true?
Yes.
That's crazy. Before Halloween, I mean,
Right?
It's like creeping up, right? Used to be they'd wait till after Thanksgiving. Now, they don't even wait till after Halloween. Pretty soon it's going to be like July 5th, right? Right after the 4th of July. Christmas stuff will come out. Anyway, so I never hardly go to the store, so I don't know what's going on there. But anyway, it's like shopping at Target, and it's a 2-for-1 deal. If you go Christmas shopping at Target, and it says, hey, these things are 2-for-1. 2 of them in the store, you pay for 1 going out of the store. That's what roots do. They're 2-for-1. So 2 2s in, 1 2 out, and they're gone. 2 3s in, 1 3 out. They're going to multiply when they come out just like they were multiplying when they were in, no difference. And they're gone. So what do we get? 2 times 3 on the outside, 6. What's left on the inside? That leftover 3 that couldn't come out. 6 root 3. Remember that kind of stuff? Simplifying square roots? So the root of 108 is 6 root 3. Like I said, so what's it called? The Casio Natural Display, I think will just do it automatically for you. Great. You got that? Great. Maybe now you want to go buy one. Anyway, 6 root 3. I am a salesman. I get a small commission for those. Every calculator that's sold. I'm kidding. All right. Square root of, so this is 6 root 3, the root of 108. 6 root 3. So now, why did we do all that? Well, that's the focus. That's how far to the focus points from the center. So I, again, have to go back to the center point. Here, let me do this. So the center point, what was the center? 4 minus 4, that's the center. And then I have to add 6 root 3 and subtract 6 root 3 from the center, from the x-coordinate, because it's right and left from the center, isn't it? So here we go. So the foci, I'll put them up here. So the foci points are what? 4 plus 6 root 3, comma, negative 4, and 4 minus 6 root 3, comma, negative 4. And we're done. You can't add those. Remember from your algebra days? You can't add or subtract when one of them has a root and the other does not. They're unlike terms. You just got to leave it. So we're done. We found everything. We found the focus points. We found the vertices. Got the picture. There it is. Good. Questions on ellipse? Okay, let's take a look here. So this one, this one's going to be kind of tough, kind of tricky. In fact, I think I'm just going to go to a fresh screen. What is it, number 13? I'll just put here, what is it? It's x squared minus 6x plus 16y squared plus 64y. 64y plus 9 equals 0. And they basically want me to find everything in the world. That's basically what they're asking for. All right, so find everything in the world for this question. Okay, well, basically, you know what we have to do. In the end, we have to get it like x minus a number plus a number squared, and y plus or minus a number squared over whatever equals 1. We have to give it that look. Lots of plastic surgery, lots of wrinkles to remove. We have to change it and make it look like that so that we can graph it, huh? We can't graph it until it looks like that. So we have a bunch of work to do. So let's do that. Bless you. So here we go. So first off, we got the x stuff and we got the y stuff. Oh, let's just jump that 9. Just get him out of the way. He's negative 9. So we have the x stuff, leave a blank. The y, you got to factor out the 16. We good to there? Everybody see what? So let me write a note of that on that because that tricks a lot of people. Number in front of must factor out. Everybody see that? That's really important. There was no number in front of x squared, so I didn't have to do that one, but if there was, I would have. So remember when we completed the square for the parabola? This is even harder because of the factoring out number. Good so far? You ready? So, what number goes right here? And what number goes right? Remember, we're going to give them just the number they need, the completing number. Remember how that works? We're going to give them just the number they need to complete them so that the x thing will factor as the same thing twice, and so the y thing will also. Remember, that's the game plan. Give them just what they need to do that. Okay? So what do they need? Yeah, how do you find that number they need? What do you do? Take the middle one, put it over 2 squared, which is negative 3 squared, which is 9, plus 9. Good. And whatever you do to one side, you have to do the other to keep the balance. Good for the x so far? Mm-hmm. Does that make sense? It's always the middle number. It's always mid over 2 squared. Mid over 2 squared. It's always like that. Mid over 2 squared. Mid over 2 squared. Like that. Like good? Mid over 2 squared. So that tells you exactly what you need to add to both sides. And now, these 3 x's, they will factor. These 3 will factor. And how do they factor? X minus 3, huh? In other words, x minus 3 squared. See how we're giving it the look it needs? We made it a square. We completed it. We gave it what it needed to become a square. Is that good? Now, can you do it for y? Go ahead and do the same thing for y. But make sure you add to the right side what's appropriate. Think carefully about what's appropriate. This doesn't go away. Just last night, I was looking over my daughter's exam. She's taken calculus up at the Clovis Community College, and she's in a higher calculus class, and she had to do this exact thing on a three-dimensional kind of thing. And it was completely this way. She had to do it for x, y, and z. She did it all right and wrote one small number wrong in the middle, but the whole answer was right. The teacher took off points, even for a mistake in the middle, even though the final answer was correct. See, there's teachers that are meaner than me. So you have to be, this is important, this matters if you want to go forward in math and science. This does not go away. So what's the number we need here? Take the mid, put it over 2 squared, which is 2 squared 4. It's always positive, by the way. The completing number is always positive because it comes from squaring. See, it was negative at first here, but then it's positive after you square. It's always positive, the completing number. Add 4. Okay, now, here come. I hope you think well with me. Think well. What do we need to do on the right side?
64.
Good. Think about what I really did to the left side. I didn't just add 4. You think, yeah, you did. You added 4. Right. But I added 4 under the influence of a 16. You see, if I was to multiply this out now, there wouldn't just be a brand spanking new 4 there. There would be a brand spanking new 16 times 4 there that was never there before. Right? That's what I really did to the left side. So that's what I must really do to the right side to really keep the balance, right? By putting a 4 under the influence of a 16, I added whatever 16 times 4 is to both sides. It's 64. So I've got to also add that to the right side. Does everybody see that trick? You got to be careful. You got to really affect both sides the same. Not just appear to affect both sides the same. All right, is that all good? And so now that'll factor, if I can erase that now. Good. That will now factor. So let's do that. Okay, so these three, so it's plus 16. This is y plus 2, y plus 2. In other words, y plus 2 squared. See how we made them both squares? This side, the 9's cancel, and we just get 64. We're good. We've almost got it having the right look. What do we do now to finish the look? Got to get a 1 over here, huh? So divide through by 64, 64, 64. 16 goes into 64 4 times. So we get x minus 3 squared over 64 plus y plus 2 squared over 4 equals 1. There it is. Now it's got the look we need. We can graph it. All that's just to get it ready for graphing. It's all the preparatory work. Good? Ready for to move it on? So x minus 3 squared over 64. You got that? I'll write it on the new screen here. I can't remember. What was it? Y plus 2 squared over 4. Okay. Equals 1. Okay, so there it is. It's number 13. There it is. So this is what? 8 squared. And this is 2 squared, as you know. So let's graph it. Can you graph it from there? So go ahead and put the center on. Center is, what's the center? Yeah, remember it's opposite, opposite. Opposite, opposite, so it's 3, negative 2. There's the center. 3, negative 2. It's right and left 8. Can I just go dot, dot, dot? You got the rest, right? That good from there? All the rest, find the focus points, blah, 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 blah. Is that okay? Or maybe I'll find the focus points with you. How about that? It's right and left 8, up and down 2. Up 2, down 2, right? Up 2, down 2. I just want to get on to some of the harder ones. So there's the ellipse, like that. Right? So the vertices. How do we take the vertices? We take the center, 3 minus 2, and we add 8, and so we get 11 minus 2, and we subtract 8, and we get minus 5 minus 2. Good on that? Add 8, subtract 8. Again, this one's wider than it is tall. And then for the focus points, let's find those. Focus, so we use, a squared, minus b squared, huh? Here. I'm going to run out of room. Let me put it up here. So a squared minus b squared is c squared cb, where the focus points are. What's a and b in this one? Yeah, 64, a squared and b squared. 64 minus 4 is c squared. 60 is c squared. Root it. So the square root of 60. Are you guys okay with simplifying square root of 60? Square root of 60. 4 times 15. 4 is 2, 2. 15 is 3, 5. Remember all that from your algebra days, breaking down 60? So it's a 2-for-1 deal at Target. 2 2s in, 1 2 out. What about the 3 and the 5? The 3 and the 5 cannot come out because there's not 2 of them. So they just remultiply and stay as they are, 15. 2 root 15, so that's the focal distance from the center to the focus points. So again, so for define the focus points, you got to take the center, 3 negative 2, and you got to add 2 root 15 and subtract 2 root 15 from the x-coordinate of the center. Okay, so let's do, so we finally have it, so it's 3 plus 2 root 15, negative 2, and 3 minus 2 root 15, negative 2. There we go. That good? It's really warm in here, isn't it? Mm-hmm. This is kind of crazy, no? Michaela's okay? Feels like a sauna or something in here to me. No? Some of you people have jackets on and stuff. I don't know. This is crazy. I don't know why. It's like a lot cooler in the hall, right? A little cooler. I don't know. I don't know. This, we have no control. This like does nothing. It's just like fake. We have no control. Sorry. Maybe I'll ask the department, but nothing soon's going to happen. All right. So number 15, here we go. So 16x, well, yeah, let me let you, rather than me do it right away. I think you'll get more out of it. So give that a try. Complete the square. Let's just complete the square and stop there. Right. All right, I'll keep moving. I can't believe some of you guys have like sweatshirts and stuff on. I'm hot. It's funny how different people are. My wife is always cold. And one time we went to, we were in the, San Francisco, no, L.A., and one of those science museum places where you go up to the thing and it shows your body temperature, like shows you red or blue in this image when you stand in front of it. You ever seen those at science museums? Yeah, so my wife and I are there. We stand up in front. She's blue, I'm red. I'm like kidding her, like, what's wrong with your body? Why don't you have circulation? What's going on there? Anyway, so that's funny how different people are. All right, so maybe I'm the one with the problem, over circulation. All right, so what we have to do is organize the x's and the y's separately. So 16x squared, 64x, put those together separately. Keep the x stuff separate, and then you got to keep the y stuff separate. 9y squared minus 90y, and then the 145, just toss it to the other side. Is that good? So we got to organize the stuff, and then you got to factor out that 16, right? Factor out that 16, and leave a blank. And factor out the 9, leave a blank. Good there so far? I'm assuming you did all that already. Is that making sense? All right, so now we need to find the middle number, so you the completing number, so take the mid over 2 squared, 4. So add 4 right there. That good? That's the completing number. And what did I really just do to the left side by adding a 4 there under the influence of a 16? Well, it's whatever 16 times 4 is, huh? That's really how I affected the left side, and that's 64. And now over here, take the middle term, over 2 squared, negative 5 squared, 25. Add 25 to this side. So 9 times 25, what's that? 225, isn't it? That's what I really did. So add 225, right? Because 9 times 25 is 9 quarters. Yeah, 9 quarters is $2.25, right? So 225. So add 225 to the right side as well. Is everybody okay with those steps? Those are the major steps. Anything I can help with that on? Okay. All is good? So then the left side is going to factor. Can I erase this then? I'll erase some of this. Okay, so this is 16 x plus 2 squared. This is 9y minus 5 squared. The other side, I don't know. Whatever your calculator tells you. What's 225 plus 64 minus 145? What is it? 144? Thank you, Michaela. 144. Good. Good to there. Last step to give it the right look. Divide by 140. Make it a 1. We always make it a 1 on the right side. Divide through by 144. 9 goes into 144 16 times. 16 goes into 144 9 times. There we go. Now it's got the right look. The rest, can I just go dot, dot, dot? You know how to graph it from here, right? Well, actually, I want to find the, maybe let me find the foci with you, because this one has one extra wrinkle. Maybe I'll do it one more time. I don't want to use up all of our time. But, yeah, I'm going to use up all the time. That one's taller than it is wide. So you're going to need to add and subtract to the y coordinate for the foci. Does everybody see that? See, the y number is bigger than the x this time. We haven't had one of those. Right? So this will be x. Maybe let me just do one step on that. I just feel bad you're going to not know how to do that. Over 9 plus y minus 5 squared over 16 is 1. Right? Everybody got that copy down? Is that okay? On that, right? It'll be on YouTube. Yeah. So at this point, notice the y number is 4 squared. The x number is 3 squared. So when it comes to the graph, and the graph is back to up 5, so there's the center. The center. Back to up 5, opposite, opposite. Oops, kind of not, better move that over. There's no room for that. So back to up, right there's the center. Back to up 5. It's going to go right and left 3. And then up and down 4. So it's more up and down than it is right and left, isn't it? A little bit. It's a little bit taller. A little bit, that's terrible. It's a little bit taller than it is wide. So what does that mean? That means the vertices are here and here. Remember, the vertices are always the longest edges? So the vertices are top and bottom. You guys with me? So the vertices, to find the vertices, which is up 4, down 4, you're going to need to add 4 and subtract 4 from the y coordinate, right? The vertices are up and down. So that's going to be minus 2, 9. And then when you subtract 4, it'll be minus 2, 1, won't it? Those are the two vertices, the up and the down. And the focus points, same thing. They're up and down also. Remember, everything's always on the major axis. The vertices and the focus points are always on the major axis, the longer direction. This one's taller. So to find the focus points, you know the equation. A squared minus b squared is c squared. Which one's A? A is always the bigger, isn't it? So this is a squared here, and this is b squared there. A squared's under y this time, isn't it? Mm-hmm. Guys, tracking with me on that? A is not always under x. Is everybody hearing me on that? Mm-hmm. A is not always under x. What is A? A is wherever the bigger number is. A, with the A and the B, the A is the bigger number. So the a squared is under y this time because 16 is bigger than 9. So a squared is the 16, b squared is the 9. Subtract that, c squared is 7. So c is the root of 7. Right? C is the root of 7. So that means you add root 7 and subtract root 7 from the y coordinate because it's up and down. So the focus points, the two foci, are negative 2, 5 plus root 7 and negative 2, 5 minus root 7. All right. I did the whole problem, even though I said I wouldn't. There we go. All right. I better move on all that. Just wanted you to see one that's taller than it is wide, that all the work is on the y coordinate up and down instead of the x coordinate sideways. All right. I'm not going to do the whole way. Just to want to show you one thing. So there's one little trick that I just remember years past fools people. So as you look at this, x squared is done already, whereas y squared and y to the first, so must complete the square. Yeah, do you see that difference? X squared done, because there's no x to the first power term. Does everybody see that? We have an x squared, but no x to the first. Well, then you're done. It is squared. It's a square. It's x squared. In other words, it's x minus 0 squared, if you want. Right? It is a square. Nothing to do there. Whereas so you only do the square thing when you have the second power and the first power term. X squared and regular x. Or y squared and regular y. Right? Everybody see the difference? So I got to do that on y. I don't got to do that on x. X is done. So x is done. What about y? You know the whole thing. Find the completing number. What is that? Grab the middle. Minus 24 over 2 squared minus 12 squared, 144. So the completing number is 144. Add 144 to both sides. These three will factor. It's y minus 12 squared. This is 48. X minus 0 squared. This is 144. ... Divide through by your 144. You got it. Everybody good on that? So the x squared's already done. Just wanted to make sure you saw that. Nothing to do on the x, only on the y on that one. All right, moving on. Okay, so number 18. So we got two vertices and a focus. And from all that, find the equation. So that's a little tricky. Picture definitely helped. So back 2, down 4. Back 2 up 8, back 2 down 4. So those two dots are vertices, aren't they? And the focus is back 2 up 4. Right here, this is a focus point. Okay. All right, just from that, can we figure out the equation? Mm-hmm. Let's start with the center. Can you find the center? Can you find the center of that shape, the center of that ellipse? It's got to be the middle of those two vertices, right? Because the vertices are the edges. Is this, by the way, is this ellipse up, down, or right, left? Is it taller or wider? Taller. It's got to be. Because, remember, the vertices are the longest edges. And if the vertices are up, down, then it's got to be taller than it is wide. Right? Remember that? Vertices are the longest edges. So when they call those vertices, those are the longer edges. Okay, so that's top and bottom. So I got to find the middle of those two. That'll be the center. How do you find the middle of those two? Well, this one's at up 8. This one's at down 4. So what's the middle of 8 and negative 4? How do you find the middle of two numbers? You got an 80 and a 90 on 2 exams. How do you find the middle of your 2 exam scores? Add them and divide by 2. Averaging is middling, right? When you average 2 things, you add them and divide by 2. That's how you find the middle. So I take 8 plus negative 4 over 2, which is what? 4 over 2, which is 2. So right there at a height of 2. So you guys good with that? That's something you need to do. It could be on the test. I don't exactly remember. But right there at up 2. Oh, I just got the practice exam up last night. So it's available. Practice exam number 3 this weekend. If you want to look at it, that would be wise. Practice exam number 3 with all the answers is up. And you'll notice part 1, no calculator at all. No calculator at all for 8 questions on part 1. Part 2 is graphing calculator. It's going to be the same thing for exam 4. It's not hard stuff. I'm not going to make you do big old honking numbers with no calculator. I'm not interested in wasting your time or your ability to add and subtract gigantic numbers. I'm just making sure you can really solve the ones by hand and not just plug numbers into your calculator, especially when it's multiple choice. Just plug in the answers with your calculator. I'm just making sure I'm getting the honest truth about what you really know. So part 1 is no calculus. Remember, my teaching is I aim not to surprise you. So no surprises. Look at that practice exam. We'll do it next week on Tuesday in class. But part 1 is it's only, I think it's 8 questions on part 1, so much more on part 2. But it's like ones like this, You don't need a calculator for this, right? Unless the numbers get really big. I'll make sure the numbers aren't too ugly. Not hundreds and stuff like that. All right, so here we go. So there's the center, which is back 2, up 2. There's the center. back to up to the middle of that thing. Now, where do we go? So we got the center. So right away, if remember in the equation it's opposite. So the equation is going to be x plus 2 squared over something plus y minus 2 squared over something, right? You with me? Get this out of the way. Equals 1. Because the equation to the center is always opposite. So right away I can eliminate this answer and that answer. They're not right. Good. Okay. Now, how do we find out what goes in the bottoms of the x and the y to finish out the equation? What do we do? So whatever goes, it's the longer direction is the y. So how far up and down, that's whatever goes underneath y, and how far right and left is what goes under x, right? So how far up and down? Well, how far from 2 to 8? 2's the middle, 8's the top. How far from 2 to 8? That's up 6, isn't it? So this must be 6 squared. Good? Now how far over here? I have no idea. I just kind of drew that in at random. I don't really know anything about how far right and left. I know it's less wide than it is tall, but that's about all I know. How do I find this over here? What do we do? All right, I know the focus, so I do the focal equation. Right? I do know the focus. I use that to find it. Now, this one that's missing, is this A or B? Is it A or B over here? Remember, A's the bigger. Remember, A's the bigger. Which one's bigger, up, down, or right, left? Up, down. So this is A. So this other one must be B. Everybody see that? Remember, A and B are interchangeable. A is always the bigger. The bigger on this one's up, down. So this is A. So this must be B. So write the focus equation. A squared minus B squared is C squared. A squared is 6 squared. I'm looking for B squared. What is C squared? Everybody see it's 2? Everybody see that? Because from here to there, remember, C is how far from the center to the focal point, isn't it? C is how far from the center. How far is it from here to here? From a height of 2 to a height of 4. It's 2. C is 2. Does everybody see that? They gave me the focal point is up 4. The center point is up 2. So from 2 to 4 is 2. C is 2. How are we doing with all these details? You guys doing okay? So then C is 2. So then this is 6 squared minus B squared. Well, I should just make that 36, huh? 36 minus B squared is 4. Kind of running out of room here. Let me bring it over here. I'm totally running out of room. 36 minus B squared is 4. So then subtract 36. And minus B squared is minus 32. Divide by 1. B squared is 32. So you could just put 32 here. You don't need to square root it and everything. We want B squared anyway down there, right? Y'all with me? I'll just stick the whole 32 there. B squared is 32. So there we go. Is it A? Yeah, it's A. We got it. Oh, I didn't even need to go that far, did I? As soon as I had the 36 under Y, I knew it was answer A. Anyway, I did the whole thing. There we go. We good on that?
Anyways.
We did more than needed. Is everybody okay? Questions on that? You able to focus with the heat? Is that good? All right. These are hard. These are important. These are tricky. This takes time. Okay, so give me a couple focal. I'm just going to do it quick. That one of them is over 6 down 4. 5, 6. Over 6 down 4. And back 2 down 4. So there's the 2 focal points. Okay. Now, can you find the center? Does this ellipse go more up? Is it taller or wider?
Looks like it could be wider.
This ellipse is wider because the focal points are sideways, huh? It's going to be something like that, isn't it? So anyway, can you find the center there? Find the center of those 2 focal points. Center of the 2 foci will be the center of the ellipse. So this one back 2, this one over 6, right? We know it's somewhere down 4. So back 2, it's somewhere on this line right here. Right, so we know it's down 4. It's just about how far over it is, right? So we got the back 2 and the up 6. So add those up and divide by 2. What is that? 4 over 2, 2. So right there at 2, there's the center over 2 down 4. Good? So that's the center of the ellipse. Now, from there, what do I do with this length of major axis is 16 thing? What does that mean, length of major axis? What's the major axis? It's sideways on this one, right? It's the longer direction. So when they told me length of major, they mean from edge to edge is 16. From here to here, from there to there is 16, is what they're saying. So therefore, it's 8 each way from the center, isn't it? So from the center, you go right 8, and you go left, not to the focus, it's beyond the focus, right? Focus is inside. It's all the way there. So from the center, it's back 8 and right 8. So that means you add 8 to the center. This will be 10 minus 4. Anyway, we don't care. We don't need those coordinates. Who cares? It's just 8. What I care about is it's 8. So now I can write the equation. Here we go. Oops, come on. Write the equation here. So it's x, y. So what's the center? X, y, 2 negative 4. So x minus 2 squared, y plus 4 squared. Kind of scribbly there. And what goes under the x? What goes under the x number? How far right and left? 8 squared. Right? What goes under the y number? How far up and down? How far up and down? How do I find out how far up and down? The focus equation again, huh? We like use that thing every time, don't we? You guys with me? So I got the x. It's right and left 8, so that's 8 squared. But the y, now is this right here? Is the 8 the a or the b? It's the a because the a is the bigger one, and this is wider than it is tall. That's the a. So what I'm looking for is b. So in the focal equation, a squared minus b squared is c squared to find the foci. So what is c? I know a is 8 squared. A squared is 8 squared. I'm looking for b squared. What is c in this problem? What is c always? How far to the focus point? From the center to the focus point? So from the center to the focus point is at 6, center's at 2. From 2 to 4, sorry, from 2 to 6 is 4. 4 squared. Like that. Am I good? So 64 minus b squared is 16. So solve for that and you've got it. Yeah, so you just have to solve that. I'm just running out of room and time, so I'm going to move on. Just solve for b squared and you got it. Is that good? Questions on that one? Well, this might be our last equation one. All right, they're telling me the center is 2, 4. 1, 2, 1, 2, 3, 4. Boom, right there, 2, 4. Focus is 2, 7. So there's the center. There's the focus. and it contains the point 3, 4. So here's the focus, the center, and it contains the point right here. This is 3, 4. This is 2, 4. This is 2, 7. All right, you with me on the graph there? So I put the 2, 4 in the center, the 2, 7 in the focus there, and the 3, 4 is some other point it contains. What does that mean, contains? It hits it. It's on the edge. 3, 4 is on the edge. Is this ellipse taller or wider? Taller, because the focus goes up from the center, right? Focus is always on the long direction. Now, it doesn't hit the focus. It goes above the focus and below, and it hits 3, 4. You with me on that? Remember, it does. The focus is inside the shape, right? Not the edge up here is some vertex point. I don't even know what that is. I don't think I even care. There's some other vertex point up there above the focus, right? So 3, 4 is a point on the edge of the ellipse, isn't it? What does it mean whenever they give you a graph of any kind? We're about to do it with word problems too. And they give you a point on the picture. Any graph, any time in math, when you've got a point on a picture, what does that mean about the two numbers, 3, 4, the x and the y, of that point that is on the picture, on the graph of the shape? What does that mean?
It means it exists on the line.
Means it what?
Exists on the line.
The line, okay, we don't have a line here. So what do you mean? So what does it mean about the equation? It means it makes it true. That means if you plug the x and the y numbers in to the equation, which I'm going to try to find here in a minute, it'll make it true. Is everybody good with that fundamental thought? That'll come up all the time in math as you go forward. This class, calculus, 1, 2, 3, and onwards. Always give you a point on a picture. Remember what a picture is all the dots that make the thing true, right? So if a dot is on a picture, it makes the thing true. And they want you to use that fact. Okay, so here we go. So it's x, no, what's the center? 2, 4. So opposite. So x minus 2 squared, y minus 4 squared equals 1. Numbers below x and y, I don't know. Hey, I do know. How far to the right from the center? Only 1. Does everybody see that? Because, right, we're just going from 2, 4 to 3, 4. That's only 1 to the right. So that's what's underneath x is 1 squared. You guys with me? Remember, what's underneath x is how far right and left. What's underneath y is how far up and down. I don't know how far up and down, but I know how far right and left. It's right 1 because center's 2, 4, and it's hitting the point 3, 4. That good? Now, what's underneath y? How do I find that? Well, is it A or B? What's underneath y? Is it A or B? It's A squared because it's the bigger. Right? It's bigger up, down. Right? A is always the bigger. Okay. So I got to find A. Can we go to the focus equation? Let's go to the focus equation like we always do. A squared minus B squared is C squared. What is C? How far is it from the center up to the focus point? From 4 to 7? 3. A squared is what I'm looking for. B squared is 1 squared. There we go. A squared minus 1 is 9. Add 1. A squared is 10. So there we go. A squared is 10. We're done. Is that too quick? You okay with that? A squared is 10 from the focus equation. So we got the equation. Michaela? Just 10, right? Because see this equation right here? A squared is 10. So A is technically the root of 10. So you could write it root of 10 squared if you want, which is just 10. Make sense? I know people get confused by that. Is that okay? All right, I'm going to move on if you're okay. 4. All right, so they're talking about a bridge is a semi-elliptical arch. So that means, a semi always means half. So a semicircle is half a circle. A semi-ellipse is half an ellipse. So we're talking about a half an ellipse, a bridge that's half an ellipse. its span is 160 feet. That means 160 feet wide, right? And the max height is 20. That means that's 20, right? Choose a suitable rectangular coordinate system. Find the height of the arch at a distance 20 feet from the center. So in other words, let me just put this point right here on the graph. This is over 0 up 20, isn't it? And they're asking, when you go 20 feet to the right, what's the height? There's their question. When you go 20 feet to the right of the center, how high up? How high up is it? That's exactly what an engineer would need to figure out if they were building a semi-elliptical bridge under a freeway or something. They need to know, where's the right lane and can semi-trucks fit underneath that? How high will it be 20 feet to the right of the middle? They would need to know that kind of thing, right? So before they build it, they would need to do the math and not just build it and hope for the best, right? So they'd have to calculate the heights. So how do we figure that out? We're going to need to get the equation of that ellipse. I've given this kind of question on the exam, this next exam we take many times. I honestly don't even remember if it's on this exam or not. But I'll tell you this, many times I've given this kind of a question, semi-elliptical bridge, find the height, and like half of the class, literally, maybe 40%, I don't want to exaggerate, of the class will use the equation y squared is 4ax. They will use the parabola equation. I don't know what to do about that. I even tell them in advance now. I go, what's that word say there? Semi-parabola? Semi-ellipse. So maybe I don't know what it is. Maybe the thought in their mind is if it's only one branch, that's always a parabola or something. Not true. Let me just say that ain't so. You can take half of it. So ellipses have different kinds of curvature than parabolas. It's not just that one's half. It's that they bend at a different rate. So you need to use the right form. And they're telling you, they're not beating around the bush, semi-elliptical. So don't be fooled by that. But I did this last time, and it seemed to make no difference. I must have been doing the Charlie Brown teacher voice. I mean, I feel like I'm telling them straight out. I couldn't believe it when I graded it. I'm like, what is this? I mean, it's just a zero. Just 0, 0, 0, 0, 0. I mean, it's the wrong equation from the get-go, right? If it says ellipse, you got to use an ellipse equation. You can't use a parabola. Now, I know there's also parabola ones, but I'll tell you. I'll say semi-parabola or semi-ellipse. It'll say, right? Does that make sense? Nobody's going to do that, right? That's what I did last time. And literally almost half of the class still did it. I'm not sure what I can do about that. All right. So I hope that helps. So we're going to use the ellipse equation, which means x squared over a squared plus y squared over b squared equals 1. I put this ellipse, the center is 0, 0 of that ellipse. What's the, do I know a squared? What's the a squared? Good, because a, how far to the right and the left? Must be 80 each way, right? Right 80, left 80. From this, because 160 all the way across. So the a squared must be 80 squared. Everybody good with that? So far, so good? Okay. And what is the b? How far up from the center? Well, 20. They told me it's 20 high, so that must be 20 squared. Yeah, that's kind of nice. This one's not too bad. Good. Okay, we got that. Is that good so far on that? Is that making sense? So it's 80 right, 20 up. So x is always how far right and y is always how far up. Okay, now, what do I do to answer the question? Well, you know what it is? It's really just a point on the, I'm really wanting to find that point on the ellipse, which is over 20 up h. Does that make sense? See that from the center, that point is over 20 up h, isn't it? That's the coordinates of that dot. So if I plug in 20 for x, right here, 20, and I plug in h for y, I can solve for that height. So 20 squared over 80 squared plus h squared over 20 squared equals 1. Does that make sense? I literally just plug. So here's what I was talking about a minute ago when I said a point on a picture, you can plug it into the equation and make it true.
Do we have to put the square even though, isn't it practically already, A is just 80? Or do we actually have to
A is 80, but okay, one more time your question.
You know how A squared equals 80? So we actually have to square the 80 also?
A squared does not equal 80. A equals 80.
Oh, okay.
Yeah, A is how far right and left. So yeah, it is 80 squared. Yeah, that's a really good question. That'll come as you do these problems. Because I know that's question's a good one. That's a mistake a lot of people make. Is it 80 or 80 squared? All that little stuff. There's simply no shortcut for time. You have to do these problems again and again and again. I know it seems crazy. I was talking to a student in another class, and it alarmed me because she's a very good student. She's doing well. She's getting an A, I'm pretty sure. And she said to me, "Oh, it's just too much work. I just want that practice exam, Mr. Heron, because I can't learn all these problems." I thought, ooh, is that how people feel? And she's a good student, so for she's saying that, I'm thinking that's what most everybody said. Let me just tell you the truth. I mean, this is junior college, and here we are weeding out those who are really university material or not. And I'm telling you, I'm a math person, right? I've always been since a young age. But I had to do every single solitary homework problem until I understood it, and I went to help to my teachers all the time on the ones I didn't understand. I just think there's a lot of fooling ourselves as to what it takes to make it in math science. You cannot play games. You need to. I mean, I'm being nice. You get to the university, they're not going to give you a practice exam exactly like the real exam. Are you kidding me? You'll be lucky if they tell you review these topics. They're going to say you had the homework. Know that stuff. It'll be on the test. And you got to be mature about that. You've got to master that homework. I mean, really, just be honest with yourself. If you want to go to a university and get a bachelor's degree in math or science, you have to be the kind of person who's doing all the problems and mastering them. You have to give it that kind of time. It requires that kind of commitment. It means to take your life. That's what it means to do for these 4 years of your life. You won't make it without giving it your life. So I just want to be straight. I just think if I was to say number one, what's the problem with math and science? People are not willing to do what it takes in America to make it through math and science classes. That's really it. So let me encourage you guys. I mean, I know you're busy. I'm not saying you're lazy, but I'm saying commitment level, right? If you're working 35 hours and taking 18 units and you're only trying to give this, only doing half the homework, it's not going to happen. Bad things are going to happen. To your math science grade. So anyway, so that's what you got to do. I'm glad to help you. Come see me, get the tutors. The help is there, but you got to give it time. There's no substitute for hours and hours and hours doing these problems over and over again. All right. Well, I hope I'm not totally ignored for your benefit on that. All right. So then we just got to work this out. I would just use my calculator here. So 20 squared, what's that? 400 over 80 squared, what's that? 6,400. Plus h squared over 400 is 1. Like that, I'm just doing the calculation. Then, is that something nice? What's this on the calculator? 400, 1/16. Whatever. Just move it to the other side. Just move that to the other side. I'm just going to move it. I'm going to get this all out of the way. Just move that to the other side. And we'll see what we get. So h squared over 400 is 1 minus 400 over 6,400, like that. And then final step to solve for h squared there is multiply both sides by 400. Like that, right? And so that's h squared. Oh, so then you got to root that, don't you? So it's the root of 1 minus 400 over 6,400 times 400, the square root of the whole thing. Everybody see that? So just type that into your calculator. Everybody see what we did there? Was that too quick? That will give you the height. I didn't bring my calculator. Somebody have that number? Anybody? Anybody got a calculator? Can I borrow your calculator? Thank you. So let's see what we get on that. So square root of, let's see, 1 minus 400 divided by 400 times 400. Okay, I'm getting 19.36. I don't know, two decimal places. 19.364, yeah. 19.36. Y'all getting that? Well, thank you. On that? All right, I got to move on. Glad to help you. Come see me. I'm going to need to wrap up